So starting with our presentation on big data, predictive analytics and Spark integration, what we would like to introduce is a framework that we have developed at SAP, partly acquired through an acquisition. If you've ever heard of a company called KXCN, Knowledge Extraction Engine, this is now part of the SAP portfolio, where we have a framework which can be used to highly automatedly create predictive models. And that is something that we have made available in the Spark framework with native Spark technology, which we believe will bring lots of benefits to various kinds of personas, including, of course, data scientists as you are. And you may wonder, you being data scientists, why bother automating anything? You know, you have invested a lot of time and effort to being able to produce predictive models yourself. But sort of truly stating the obvious, this is more of a reminder. You know, complexity, of course, is rising, data volume is rising, more and more technologies, specifically in the big data Hadoop area, things to learn, things that were up to date 2 years ago, today might already be obsolete. So, of course, it's extremely hard to keep up. But at the same time, whilst complexity is growing, the expectation of companies, the business users, is also growing to deliver results as quickly as possible. And very often it's not just about the one perfect model, but about producing many, many models at very high quality in a very efficient time. And so there's clearly let's say, a lack of scalability in catering for all the requirements that are coming up. And this is where we see the automated approach kicking in extremely nicely. And depending on sort of how deep you are in the data science area, maybe you're starting out, maybe you bring a wealth of experience with it, we believe the benefits of that automated approach depends a little on where you're coming from. On the left-hand side, if you're a data scientist, we believe it will help your productivity. That you do not have to create and train one model after the other over and over again, which after a while might also become a little boring because you have created the model before, you have to maintain it over time, it just needs doing. So we see ourselves as an additional capability, one more tool in your portfolio to help tackle the business cases that you're working on. If you're more of an analyst, so maybe not that deep in the data science area yet, possibly, then we believe we open up the world of predictive analytics to you in an easy manner, without you having to know all the algorithms that are available, all the assumptions that are placed on the algorithms, how to verify these assumptions, and if they're not met, what to do. You know, so it opens up the world for, let's say, people who are less deep in the topic. And if you are thinking more from a managerial point of view, you're a company, so to speak, that also here we open up the world to predictive analytics that you can really scale on big numbers. So really scalability to use models wherever they're needed. And maybe you might say, well, if you're a data scientist, then you can create your models with little effort. And here's a screenshot from the MLlib website, where we have a logistic regression, and I haven't counted completely, but let's say it's about 10, maybe 12 lines of code where you can do a logistic regression. So you might say, what is there to automate? 12 lines of code, super easy, I've done it. And of course you would be right to say that at the end, that is a complete logistic model. However, in our experience, our process, of course, is much, much bigger. So if we look at the CRISP process, that I'm sure you're very familiar with, starting with a business understanding. What kind of issue would I like to solve? What kind of data do I have? And preparing the data, which very often can be creating new variables that help me describe, or help me predict my model. Then one model is created, and this is the code that we had just seen. But in reality, of course, it is not just one model. You will have to go through many, many different iterations, maybe different algorithms to find the best model possible. See if that model that you were able to find really helps your business case, and then actually put it into deployment. And deployment not just means, well, I've got the model, I've got scores, and give it to the business user, or wherever the numbers are needed. It's also about maintaining the model, keeping it up to date. Of course, as the data changes, whatever you're analyzing, we will come up with a use case on banking, which customer is interested in buying a credit card. If customers' behavior changes over time, the model obviously loses in quality, so you have to check, does the model have to be retrained? If so, it needs to happen. So this is all part of the deployment. So the 10 lines of code, we believe, is really discovering a small aspect of the bigger picture. And all these steps really beginning from, let's say, data preparation, the lower part here, we have automated in our framework. To mention the name, it's called Predictive Analytics, open to all sorts of infrastructures, Spark of course, we'll see that live with Priti, but open to relational databases, open to subsystems of course, but just to mention, we have many customers who are using this infrastructure completely detached from any other SAP technology. So if you're not using SAP yet, fair enough, there might still be ways to benefit from the approach we're introducing here. And very often the next question is, if people might get interested in automated analytics, how do you actually do it? How can you automate where people studied for years to be able to produce nice models? And in the time that we have available, I'll only be scratching at the surface. And if you'd like to go deeper, we'll be here at the stand, just on the side. Please come and talk to us and we can try to answer it more deeply. But overall, we try to follow a concept really described by Vladimir Vapnik, a name that many of you might be familiar with, so based on structured risk minimization, we have a concept where we don't place any assumptions on the data whatsoever, where given the business case you would like to solve, you just need to describe what should the model describe, and then we have a way to fine-tune algorithms to find the best possible outcome. And one thing that was mentioned in earlier presentations is missing data. That what typically can take a lot of effort. How do you handle missing data? We're here, as an example, we treat missing data as a new bucket, as something that is unique. We don't try to estimate numbers, that will be wrong anyway, but we take the information into account that there is no data. Very often there's a reason behind the fact that there is no data, which might or might not have an impact on the predictive model. And but really the whole process starts much earlier. In that crisp process, there's one step, of course, where you need to create new variables. Very often the data is very transactional. We're thinking about customers, thinking about transactions that people might have done at a bank. But to identify a customer likely to buy a new product, you need to describe the customer in one long row of data. And here we have a graphical interface that you can use, where you just link tables, and then there's a way to create time-related variables, where you don't have to go in with SQL or other syntax to say, well, filter on the last quarter, how many transactions did we have? But with a few clicks in a graphical interface, here, for example, you could say, well, aggregate me by customer for the last 2 years, by quarter, what did that person do? How many transactions? How often did he go to a cash point? What was the average amount? And very quickly, you end up with dozens, if not hundreds of variables. Also an important point, we can go extremely broad in the data set, where there's a few more examples of what these variables could be. Because we can go to extremely broad data sets to tens of thousands of columns. So where big data, in our experience, is sort of not just the number of rows or the actual data volume, but part of the complexity of big data can be the number of columns, where some of these columns will be relevant for the model, but some of these variables might have the golden nugget that helps your model along. So in combination, now when you add more and more variables, the model can improve in quality. Also, because we do variable selection, we don't try to put tens of thousands of variables in the same model. We find out which ones are most relevant. Those become part of the models. Anything else can be discarded. And at its core, what is happening here is that we're using a rich regression, where this parameter here is really added. That is the specialty of the rich regression, where there's lambda parameter multiplied with the coefficients, which helps that the coefficients of the real model don't completely get out of scale. That they don't become extremely large or very small, which can lead to other issues. By the way, we also handle correlations by calculating out the impact of correlated variables. But this lambda parameter here for us is very, very important, because we can use it to play with the number of lambda to find the best model. And here, coming back really to the concept of Upnik, where we can, after all the data encoding, for example, has happened, we can play around with different values of lambda to find the best model, which is defined by the minimized total error. So the balance here between training and generalization error. And once we have a model created, you can do that manually, even locally installed very easily in the tool. You can use those numbers, you can interpret the model, which I haven't shown here, so you can communicate to business people. It all is aimed at being intuitive, not for the person creating the model, but also people who might be interested in what are the drivers behind the model, what kind of activity should I look for or try to avoid. But once you have a model, it needs to be maintained, you need to deploy it. And deploying such a model can be done by, we call it a factory, which is a server which can know the model, which can mass produce new models. For example, you could break it down by customers, not just for the whole of Switzerland or the world. You could break it down by canton, you can break it down by zip code, it doesn't matter. So with a few clicks, you could create dozens or hundreds of models, but also it can keep these models up to date. It can automatically verify, have the numbers changed, has people's behavior changed? If so, let's just retrain the model and apply the model and score if needed. And this is the point where we believe now we can support data scientists, for example, by taking care of the ongoing day-to-day work that you just have to do, the models that just have to be very well in production, freeing up some of your time to work on other cases that you simply had no time so far to get around to. And with that introduction of the automated approach, I'd like to hand over to Priti now to focus really on the Spark topic.
Thanks, Andreas. Hello, Pete. So I'll stand here because I have to give you the real live demo, not any more the presentation slides, but I just have to set up a stage here, so just bear with 3 more slides. So we're talking about big data. You heard 2 sessions already in the morning, but we wanted to show you how actually it looks like in the Hadoop cluster and how you can build an application as a data scientist or as a developer, like the way we have done it using the automated technology which Andreas described. So can I just ask how many people know Hadoop and the related environment that we have today here in the audience? Okay, so I can skip the slides then. Well, just wanted to mention the essence here we want to say is that Hadoop is about distributed processing. It's cheap commodity hardware. But when we go about machine learning, the main challenge here is how do you do machine learning in a distributed environment? So we are talking about actually executing a single step of algorithm, like missing value, finding missing value, or calculating the weights of variables, distributed on 30 different machines. So that's a challenge here, technology-wise, also as a development-wise. How do we kind of run this algorithm in parallel, and each step of algorithm in parallel? So that's the essence here I wanted to bring in. And just in terms of us, I just wanted to share a survey here. So what came out was that Hadoop is a giant world. You know, it's also called a zoo sometimes. You might know there are stacks for doing SQL, NoSQL, ingestion, and there are stacks for doing machine learning, and so on and so on. But we chose Spark because Spark is an in-memory high-performance engine on Hadoop, and that's specially suitable for distributed machine learning. So what we did was we took Spark because that's one of the most widely used engine on Hadoop today, as of the surveys which you can see across also on the net. And we choose that because most of the companies are using, and also because it's suitable for distributed machine learning or advanced analytics type of use cases for doing data science. Because you may know the process is going to be iterative, it cannot happen on disk. It has to be in memory, sharing the results among different processes. So that's why we chose Hadoop and Spark. Now, I'm comparing on the left-hand side how traditionally any application would be written on top of Hadoop when you talk about data science, and on the right, how we have done it. So on the left, there will be typically client-server type of an architecture where you kind of transfer the data and then you perform machine learning. Whereas on the right, what we have done is we have actually written the machine learning code on Spark, providing us the benefit of distributed processing. So we call this functionality as native Spark modeling because this is natively written using Scala code. And that's where it kind of performs algorithm in parallel, collects the results and give it back to the tool to show the graphs and analysis. So only results are passed, but entire data has been distributed across multiple nodes. And we're talking about nodes, which is like a PC, you have it or I have it. And typically, just from my experience, the customers I have talked to, they would have from 30 to 40 different nodes in a single Hadoop cluster. But there's no restriction. For example, Facebook has thousands of nodes, and Yahoo has the biggest Hadoop distribution with 10,000 nodes in a cluster. So for Yahoo search engine, if you're wondering how fast it is, it's because it's been happening on 10,000 different nodes in Hadoop cluster. And that's the technology we are trying to use here in terms of a data science. This is an architecture for technical people. I can share the slides later on the booth, but we wanted to show that we have done a job framework which kind of runs every step in parallel and then connects the results in memory, and it's happening on Spark. So that's the main message here. Now, why did we do it? Before I go into the demo, just wanted to say that we tried to perform the comparison with some different machine learning technologies like Spark. You would say Spark has machine learning, there's R. There are so many choices to you as a data scientist, so what's happening in terms of performance? The right-hand side is taking for us nearly 20 minutes as compared to, let's say, Spark linear regression, which took around 60 minutes. This is again subject to the data set we took. In some cases, you may find Spark is faster, but this is a real-time scenario from one of our customers where it took us to have 18 minutes as compared to 60 minutes on Spark. So again, this is again comparison of different data set. Andreas touched upon having wide data set. Orange is a telecom company. This is a public data set that you can download. It has 15,000 columns. So every column is a call record of each of the customers. And we're trying to analyze whether the customer will churn or maybe switch the network. And this is the use case we took. Again, it was taking nearly 8 hours before doing our native Spark modeling functionality, and now it takes around like 24 minutes. So we see huge benefits. And I'm not trying to market our technology here, but there is a technology coming in from Hadoop, which is called distributed processing, and that's giving us the great benefits on performance and scalability. So with this, I'll go back to the real demo, live demo. Hopefully it works fine if it's on Wi-Fi. So if you haven't seen any Hadoop cluster, this is just a brief overview. I'm using a very small Hadoop cluster situated in SAP network. And it has 6 nodes, okay? Like I mentioned, there can be 30 nodes, 10,000 nodes. This is a small cluster, we have 6 nodes. You can see how much memory on each of the cluster, each of the node is. And once again, imagine node as one computer, yeah? So we have 6 computers here, combined together in one cluster. And I'm going to perform distributed machine learning that will get executed across these 6 nodes. So we are utilizing the power memory, CPU, and the programming that we have written to perform this distributed machine learning. So now I'll go on to the tool, just briefly showing you the concept of data preparation. So I'm connected to the database. This is actually the Hadoop cluster. So we call it as a database, but in reality, it's a Hadoop cluster. I have my data on HDFS, which is a file system. And in this example, I had 5 different files for a financial industry use case. One for client data, one for their account information, one for unstructured geo demo information. So we wanted to predict whether the customers will buy loan or not, or they will go for credit card or not, based upon what they have with us as a bank. So imagine I'm a credit analyst in a bank. I don't look like, but imagine. I have 5 different files structured in, not structured, but really present in Hadoop. As a credit analyst, I don't understand Hadoop at all, okay? So I want some tool which can seamlessly do for me machine learning and give me great benefits. I can play around as many models as I want, play around with the data, taking some information from here and there, from social networks and so, and I want to see who should I target for credit card in the next 6 months. I don't want to waste time for people. I don't want to annoy them, so I just want to find exact, let's say 500 or so customers out of my 15,000 customers who will buy a credit card. So what I do as a first step, if you remember Andrea's diagram, the first step was data preparation, and roughly people spend 60% of time just preparing the data. And here in case of Hadoop, I get as a tables, and once again as a credit analyst I understand tables and SQL, I don't understand Hadoop. So what I will do is that this is a graphical tool, I'll start creating the variables. So and just to tell you, I started with 5 tables, and every table had some information about clients, like client age, their gender, their demographic information, city, zip code, and so on. Now, what I want is that I want to find the average monthly balances and amounts in last 3 years, so I can understand what is actually driving to buy a credit card in the historical data. How much balance or amount the customers need to have before they go for the decision of credit card. So this is one example. You can take any example. So the way I do here, for example, is create an aggregate. So there are various functions. In this case, I'm just trying to show you how I can create multiple variables. So I get a transaction table. It has 1 million records. In this case, residing in Hadoop. So I'm saying calculate the average balance and amount, and here in the period setting I can say, for example, define 36 periods of 1 month. I need monthly balances. You can select quarterly as well if you want, and let's say starting 12 months before the date I would ask for a user to input. So if I'm a credit analyst and tomorrow I want to share this information with the VP of my bank, I can at the runtime change the date and say, from this date, calculate 36 monthly balances starting 12 months from now. So I can do this, and you can see the number of fields is 72. I started with 2 fields, I added 72 fields now. Similarly, I can go to filters and private settings. Let's say here I have an operation field which tells what type of operation the transaction has. Sorry for the message, for some reason doesn't work. Yeah, so I have 4 different fields. I want to find average monthly balances and amount for each of these 4 operations. I can already see some statistics like frequency and some more details in the data. So you can see already the fields are 288. So 72 multiplied by 4, because I had 4 operations, I got 288 fields. If I say I also want to see the aggregates without pivoting, you can see the fields are now 360. So what I wanted to show here is that we wanted to create as many variables as possible so that our machine learning could understand the information from it, find correlations, and give an accurate model to data scientist or to credit analyst. So that's how it is easy to create 360 variables on the fly on top of the data that I had. So that was a data management. Finally, I go to modeler. And this is where I wanted to find the credit card customers. So I already, the entire 360 fields or 240 fields I have created a sample table just for the purpose of a demo. I'm analyzing all the variables. You can see here I have cities, for example, geocode IDs, and all the aggregates that I just created on the fly. And then it already proposes me the target variable, which is in this case in the historic data, whether the target had credit card or not. So I took 3 years of historical data, added variables, and I'm trying to perform training natively on Spark to get me good benefits on performance and say which behaviors are driving for the credit card sale. So I say next. Just for the purpose of a demo, I'm selecting an operation. So in here, it's saying negotiating resources with Jan. Yarn is a component on Hadoop which manages resources for us. So as a user, as an IT admin also for your company, or for any company, you don't have to worry about managing 30 different nodes or 1,000 different nodes. Yarn takes a good care of it. So we talk to Yarn on Hadoop, it's one of the component, and then we start start delegating the operations on Spark. So we'll see it in a second. You can see here the jobs processing has been started for statistics. So as Andreas was explaining, we had operations like find missing value, do data encoding, then find weights, find correlation. For each of the process in the machine learning, we have created a job on Spark, and I can verify this also with Spark job UI. So this is a UI which is connecting to my cluster, and it is showing me how each of the jobs for each of the steps is being performed. If I want, I can go in detail and say, on which nodes the operation is being performed. So in this case, it actually took just 2 nodes. No, sorry, not 2 nodes. Actually, 5 different nodes. The same operation is being parallelized on 5 different nodes, and that's where we get the benefit of distributed processing. The model processing will be finished in few seconds, and then I can show you the results. It should take a few seconds because, it's a small cluster, and we're performing a lot of steps, and actually we had to filter in 1 million transactions in the Hadoop cluster. Meanwhile, I'll just log into the UI as a final step. So, while my machine learning, okay, this is calculated super. It actually ran in front of you. So, my training is finished, and I can see, for example, what is contributing to the target credit card sale. So here, all my monthly average balances are helping me to understand how much balances, for example, customers have in order to go for a credit card. I can drill down into detail, for example, client type. It tells me client with having ownership for a bank account are more likely to buy credit card as compared to users who do not own the account but they are just users in some way. So this is the kind of information credit analysts can see, and it helps them understand where should we target, which city we should focus, for example, or which age group we should consider to target the credit card. There are various reports available, like Andreas was showing, to see the performance, how well the performance is. So it's telling me by contacting nearly 55% of the population, I can achieve my target for 100%. Just as a final step, and this is I did actually training. So now things go wrong, and as we know, data changes. So we wanted to also talk about retraining. Now, as a data scientist, as Andreas was explaining, you invest a lot of time in building nice models, putting lot of efforts in designing the right algorithms. But what happens if data changes so frequently, especially in the big data world? So the tool, and whenever you develop an application, you have to think about how should I consider the change of data, how should I consider the dynamicness into it, and how should I automatically retrain my model. So in this case, for example, I can schedule the task every second or even every 2 hours to say, keep checking if my data changes, automatically retrain, using the model that I just use for training. So for example, for the purpose of a demo, again, I already retrained the model just in the morning, and this is the graph I can see from this UI that after retraining, how is my performance looking. So again, it gives you an idea about after the data has changed, has something changed in the variable contribution, so you can change your decisions. As a final step, sorry I'm saying final step, but this is literally the final step. This is an apply scenario. Now finally I choose a model, and I have a target data in some other cluster, Hadoop cluster. So I want to apply the data, apply the model on my target data. So I started with 3 years of history. Now I want to go live. In the next 6 months, I have an online tool as a credit analyst which will target the customers, let's say send a promotion to them. And this is done by using the apply operation, which is again automatic. You can say apply the task for every day for next 6 months and on the model that I just use for training. So it will keep on applying on every new data that comes in an online application, for instance. So yeah, using this app, you can, it's a job scheduler, but it takes the sense of modeling into place. So yeah, more or less I'm done with the demo, and just as last 2 minutes to give you 3 points as in big data needs. What we wanted to say is that big data has a lot of complexity, especially in case of Hadoop environment, and you as a data scientist or any company should think of building the tools which should minimize the operationalization of it. So we need to think about how do we take the management of our data differently from building the advanced application, and that's where we have tried to do it with our tool. And that's why we say it's not just machine learning, but it's a framework that takes care of Hadoop infrastructure and so on. And yeah, it gives you higher performance and scalability. I shared the slide, we were getting 10 to 14 times better performance as compared to doing on any other RDBMS. And yeah, it increases the data efficiency and time for you as a user. So that was a short demo, quick demo. And sorry for the Irish and Indian accent, we tried to do really fast because of the time. But you can come to the booth, I can go in detail. So,
okay, thanks a lot for the talk.